This is an example of ungrouped data because we have every single datum available to us. For example, this one, we have that many tens, okay, and then we have that many 11s, etc. So we have every single datum. Let's find the number of students in the group first, okay, which is super easy. Just the sum of this row, right? So the total number of students would be 63, which will help us in later parts. So here's the important part. Find the lower quartile and the upper quartile. Now, what is the lower quartile and what is the upper quartile? There's also another name for it. We call it Q1 for lower quartile and Q3 for upper quartile. So let's say I'm arranging these kids in terms of their height. So let's say if I cut through right at the middle, that's what we call the median, right? And if on the left hand side, I further cut this down into two halves, this height is what we call the lower quartile or the Q1. And likewise, on the other hand, this 9, I will call this Q3, the upper quartile. And the difference between Q3 and Q1, that would be the interquartile range. And also the difference between the maximum and the minimum, we call that the range. So back to our example here. So if I listed out all the 63 data in here in ascending order, for example, this 20 refers to the 2010s, and this 8 refers to the 811s, etc. You found that the 30-second datum is actually right at the middle, and that is the median. Then you start looking at the left-hand side of the median. There are actually 31 students here, and actually it looks like that in terms of the data because there are 20 out of 31 with 10 hours, right? And so if you're looking at the middle, it would actually look like this. And so the 16th 10 would be the lower quartile. Now the right hand side actually looks like this. We knew that there were only 5 12s left on the right hand side. From here we see that there are 11 13s. So if I cut this in two halves, it will look like this. And so the very last 13 would be the 16th one, right? And that would actually be the one right at the middle, and that would be our upper quartile. And so to write out the answer, Q1 is the number of hours spent by the 16th student, this one. And therefore Q1 equals to 10 hours. And likewise, Q3 is the number of hours spent by the 48th student, that is this one. And Q3 equals to 13 hours. And the rest is easy. Part C, find the interquartile range of the number of hours spent on studying by the group of students in the week. And that actually equals to Q3 minus Q1. And that would just be 3 hours. Now let's consider this example where we're studying the lifetimes of 160 batteries. Now this is an example of group data because we don't have every single number. So part A, we want to find the range of the lifetime. Okay, so range is just maximum minus minimum. So on the cumulative frequency curve, okay, you just look at the maximum point right here and the minimum point right here. So for brand A, the range of the lifetime distribution would be 160 minus 0. And that is wrong. Why? Because the 160 is simply the maximum on the vertical. And that is the cumulative frequency, right? That is just telling us there are a total of 160 batteries. But we're actually talking about the range of the lifetime distribution, right? And that would actually be the horizontal. So don't mix it up. It would actually be 28 hours. And the minimum is 0 hours. And likewise, for brand B, it would be this point, right? The maximum would be 31 hours. Minimum, 0 hours. To find the interquartile range, we need to find Q3 and Q1, right? So how do we find Q1? Q1 is actually the 25th percentile. So 160 times 25% is actually 40, right? So we want the 40th battery, which is right here. And so our Q1 would be 13 hours. So likewise, if I want to find Q3, I'm going to take 160 times 75%, that's 120, and I'm looking at the 1/20th battery, which is right here. And in this case, Q3 will be 22. And so the interquartile range of the lifetime distribution would be 22 minus 13, that is 9 hours for brand A. And so you do the same thing for brand B. Q1 would be 7 and Q3 would be 24. And so the interquartile range for brand B would be 17 hours. So finally, here's the more meaningful part. Is battery A more consistent or battery B? If you're talking about which one has a longer lifetime, maybe you look at the mean or the median or even the mode. But we're not talking about that. We're now talking about the consistency. And the more consistent the data is, the less variation of the data. And in other words, the data are more packed together and less spread out. And so we want to look at the range or the interquartile range. When you look at the range, you're actually considering the entire data, every single data piece. When we look at the interquartile range, we are focusing on the middle 50% of the data between Q1 and Q3. Why? Because we want to avoid the outliers, right? You see that both the range and the interquartile range is smaller for brand A. And so brand A definitely is more consistent.